All right, so day 2 of 3.1, here's what we're going to do. We're going to make sure that you can do exponential curves with a natural base. We'll talk about that. You'll want to be able to graph them, and then we're going to use application problems, and we're going to be calculating interest. Okay. So the first thing we need to know is what the natural base is. The natural base, things in nature tend to follow certain patterns, and we can predict how things are going to grow or decay according to this natural number. So E, it's a button on your calculator. I'll go ahead and show you. I'm going to pull up my calculator. And if I hit the second division button, that's E. That's what your calculator looks like. And there's your number. Okay. So it's somewhere greater than 2, less than 3. We don't need to know it. We'll just use the button on the calculator. So yes, you have to know how to use the calculator. Okay, so E is a horizontal asymptote for another function that I am not expecting you to use. However, f of x is equal to e to the x. We do want to know how to graph. Okay, so I'm going to pull up my graphing calculator just so that I can show you what it's going to look like. So we're going to go here, and then I'm going to use the e to the x button, and the e to the x button is under the natural log button. And so I'm going to go ahead and say e to the x. And I want to set my window. I want my window to go from -5 to 5. And let's count by ones. And then my minimum y value, I'm just going to say -1 to 5, and we'll count by ones. And then I'm going to go ahead and say graph. And there's the curve. Okay, so a couple of things that you should notice. It's increasing. It still goes through this point right here at 0, 1, and it's increasing as we move up to the right. Okay, so once we take a look at that, we want to be able to evaluate. So when this says f of -2 or f of 0.25, we're really doing that, and we're really doing that. Okay, so go ahead and pause now, and then take a look at your calculator and see what your calculator says. I'm going to go ahead and use a calculator right here and see what I get. Remember, pushing the buttons on your calculator, getting familiar with your calculator, very important. So remember, you're using the negative button, not the subtraction button. That's going to be an issue for some of us. When I do this, I get 0.135, and that's as far as I need to go. And when I do the second one, on my calculator, it's the second function under the one that says ln or in, that's natural log. And when I do this one, I get 1.284. Okay, so notice all I'm doing here is I'm taking -2 and I'm plugging it in for x. And I'm taking 0.25 and I'm plugging it in for x. So 2 times e to the 0.25, that's where the x would be. 2e to the 0.25, this is where the x is going to be. So I need to do orders of operations on this. So what I want to do is I want to hit the second natural log button, and up in the parentheses I want to hit 0.25 times -2, and then it gives me a decimal, and I'm going to do this in baby steps. So I get a 0.607, I round it up. Now I'm going to take that and multiply that by 2 on my calculator, and I get 1.213. Okay, so once you hit the e to the power, that's where you're going to get your number. So we're going to do it again, and we're going to say second natural log 0.25 times 0.25. And then I get this number. And now I'm going to multiply by 2. So I just hit times 2 on my calculator, and I get my final answer. Okay. So you want to know how to use your calculator, because that's how we're going to fill in the chart, or that's how we're going to get our test points or whatever we need to. Okay. All right. So now what we want to do is we want to identify any asymptotes or shifts. Okay. Shifts, we're talking up, down, or right, left. Okay, we're not talking about transformations such as, you know, making it fatter or taller or skinnier. Asymptotes. Asymptotes, unless you see a number out here, your asymptote is going to be, there is 0 out here. There is 0 out here. In both cases, your horizontal asymptote is going to be at y equals 0. Now, this tells me that I'm going to be making it fat or skinny, depending on what's happening. And the 5 is also going to affect. So the 5 will affect my y values, and the 0.17 is going to affect my x values. Okay? So rather than do the entire transformation, I just want to show you, you can do this on your calculator, you don't have to worry about it, but the 0.17 is going to affect your horizontal fat, skinny, and your 5 is going to affect your y value, tall or short. So the y values are going to be 5 times greater than they would for your parent function, while the x values are going to be 0.17 what they were. So let's come over here because I want to show you this. And we're going to clear this out, and we're going to enter the graph that was just on the other page. So it's going to be 5e to the 0.17x. And we want to just take a look at what that's going to do to our graph, okay? I'm telling you that the y values are going to be 5 times greater than they were on the parent graph, okay? So I'm going to go ahead right here. I'm going to go ahead and graph my e to the x graph, okay? And what I'm saying to you is that the first graph is going to be 5 times taller, if you will. The y values will be 5 times greater. So let's go ahead and graph that. And there's the 5e to the 0.17x. And there is the e to the x. Notice where the e to the x graph crosses at 1. And notice the 5e crosses at 5. Okay, so it's 5 times higher. Okay, that's all we're talking about, right? And notice if I zoomed out on this graph, oh, it's going to save that. But if I zoom out, let's do 3. If I zoom out, you can see there's my first graph, and there's my second graph. Okay, so remember, the y values were 5 times greater here, but now on the 0.17, that 0.17 means my x values have to be, well, like 8 times greater almost, 5 times definitely greater than the previous x values. So the y and the x have different transformations. Okay, so come back here. Oh, my bad. I'm going to go back here. Let me delete this. I don't want that to cover my notes. Okay, so 1/2 means that that is going to decay, correct? Because it's going to be less than 1. So it's going to come like that. Okay, now this negative there means we're going to flip that, means the x values are going to change. So what that actually means, this transformation means we're actually going to go like that. Because that 1/2 to a negative something is equivalent to 2 to the positive something. Okay, remember it was negative on bottom, becomes positive on top. So the red, this is actually a reflection over the y-axis. This is a reflection over the y-axis. The negative is a reflection over the y-axis. Okay, so when we do e functions, natural log functions or natural base functions, we're going to use the calculator. So we're not going to graph by hand. Okay, so now we're going to talk about shifts and transformations. Okay, so the shifts and the reflections. So this +2 is going to mean left 2. This is going to tell us down 1. And this is going to be a reflect because of the minus sign over x axis. And the 3 is going to tell us to stretch it by a factor of 3. Now we come over here. This minus sign means reflect over y-axis. Positive x's go to negative x's. This tells us up 4. And this tells us left 2. Okay? So the positive inside, instead of going right, means left. Okay? All right, so now we're going to do the application part. And this one is straight off the calculator. I will give you the formulas so you don't have to memorize them. But there's 2 formulas. If we're going to compound a certain amount of times per year, then we're going to use this formula. If we're going to continually compound, that's continually means, and your credit cards do this. Your bank does this, charging you interest on your home loan. They do a continuous compounding. Whereas your car loans and things like that, they say it's simple interest, and so make sure you read the fine print. We'll talk about that. But all you're going to have to need to do is use these 2 formulas. That's it. That's all you have to do is use the 2 formulas. So let's do some examples, and then I'm done. Okay, so remember, this is the amount, your balance, if you will. This is your principal. That's the amount of money you start. This is the start money. Okay. N is the number of times. T is in the number of years. R is your rate. And N is the number. Again, the N here and the N here are exactly the same. So compounded quarterly, so we want to put in the information that we have. So we know our rate. Our rate has to be converted to a decimal, so we move the decimal point over 2 times. So 0.0525 is our rate. That's the first thing we have to do. T is 6. So right now I'm just picking out all the variables. That's our start value. Oh, I'm stretching. And so that's going to be our P. And so what we want to find is how much is the amount of money we have at any given time. So quarterly, what's quarterly mean? There's 4 quarters in a year, correct? So that means N is equal to the number of times we're going to compound per year. So we're just going to plug it in. So 4,000 times 1 plus the rate, which is 0.0525, over 4 times 4 times 6. And now we're going to do that on the calculator. So all we're going to do is take out our calculator, and we're going to do baby steps. And so I'm going to show you on my calculator here first. I'm going to show you. Okay, so what I'm going to do first is I'm going to take the 0.0525 divided by 4 first. And that's going to be the N over, that's going to be the R over N. So that's the 0.013125. Now I'm going to add 1 to finish the inside the parentheses. Okay. Now I want to raise that number, I'm going to use the caret, to the power 24, because 4 times 6 is 24. And I get this number. Now I'm going to take that number and I'm going to multiply it by 4,000, because that was my P. And the amount of money I would have after 6 years is $5,469.82. So when I come back over here, my final answer, $5,469 and what did I say, 82 cents? Okay. Compounded monthly. That means how many times per year? Good. So let's plug it in. The rate is staying the same. And so now when I do that, I'm just going to use my calculator. And I'm going to do that by hand. I'm going to say 0.0525 divided by 12 equals, and I get 0.004. This is what I get on my calculator. Junk. Who cares? Plus 1. So I get that for the inside. And now I'm going to raise that to the 72 power. Nice. So I'm going to raise that to the 72nd power. And when I do that, I get 1.369, da, 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 da. And now I'm going to take that and multiply that by 4,000 times 4,000. And I'm going to get $5,477.27. Okay? So now you can do the same thing again here. I'm just going to set these up. And notice I put the formulas here for you from the previous screen. And 4,000 here. E, the rate is 0.0525. That's the rate per year times 6 years. Okay. All right. So I'm just going to fill these in. You can do them on your calculator. Pause the video if you'd like. I'm not going to do the answers for these. Daily means I would do it 365 times per year. 365 times per year for 6 years. That's a very large exponent. Okay, so remember, when you're doing this, you do the inside first, then raise it to the power, then times it by 4,000. Okay, that's the last step. All right, so that's all I have for you today. Here's your problem set on page 193. Notice you're only going to do the odds. Okay, so when you come in tomorrow, I want you to be able to tell me what the 2 formulas for interest are. I want you to be able to tell me how you can tell if a problem is reflected. And I want you to tell me if you can identify shifts. Okay? Good luck.